All right. Good afternoon, or depending on where you are, good morning to everyone. I guess we should get started with our session. If everyone can hear and see me, let me know in the sidebar chat if you see any technical problems. But anyway, we are in the session that is dedicated to applications of R and using R in production. Both are, I think, extremely important and exciting topics, so it's guaranteed that we will have a great time in the next 1.5 hours, from which we will spend the first hour with 4 talks. And then we will have question and answer sessions for like 30 minutes. Before we switch to the talks, let me just do some housekeeping and introduce myself. My name is Gergely Daroczi. I will be the session chair this time. Little bit about myself. I'm a big fan of R, and probably we have met already in some past R conferences, for example, like 2 years ago when e-Rum happened in person in Budapest, where I happened to be the main organizer. Today, it's a little bit different that we cannot meet in person. It's still a great pleasure that we can meet online and have this session and all the other sessions. So I'm very glad to the current organizers team's fantastic work on the event. Also for the attendees taking the time and joining this session. So as said, although I'm chairing the session, but I get a lot of help from the organizers, and let me just name some of them who are helping in the background with all the Q&A sessions, organizing things. So thanks a lot, Roberto, Matteo, and Andrea. Okay, before we switch to the talks, a few other important infos that I need to share. We have 4 talks, each scheduled for 15 minutes. And I will have to warn the speakers after 14 minutes. So when only 1 minute is left, and that will sound like this one. So hopefully it will not be very annoying. Sorry if you hear that, but you will know that you will have to stop in a minute. And after the talk is over, we do not have time for questions right away after the talk. But remember, we will have an upcoming Q&A session after the 4 talks. So please write your questions down in the sidebar chat using the structure that Ricardo posted and pinned in the sidebar chat. And the speakers will be happy to answer your questions in the Q&A session. Also, some useful information. If this is the first session you attend at e-Rum, please make sure to double-click on the presenter's screen so that you get a nicer, bigger picture of the slides. Also, if you're not actively using the chat, I think it's a good idea just to hide that sidebar. You can see on the top of your screen, there's a time left, and there's this strange icon with an arrow going to the right. If you click on that, the sidebar will be hidden so that the shared screen will be even larger and you can follow the slides easier. Okay, I will just stop now and let the speakers do their job. So I'm very happy to invite our first speaker today, who is Leen Jooken, who will share, I think, a really fascinating presentation about using version control system as an input that can help like actual work in collaboration. So really looking forward to learn more about that. I will just stop sharing my screen now, and the stage is yours. Thank you.
Okay, thank you very much. I will share my presentation. Okay, you can all see my presentation.
Good, and you can also disable your video just to make the quality better. Stream. Cool, thank you.
Thank you. Okay, hello, my name is Leen, and today I will present you a package I designed called Collaborator. And in this presentation, I will guide you a bit through how this idea, came to be, what exactly it does, why I think it's useful, and some results. Okay, first of all, Collaborator is a package that was designed specifically to support knowledge management for software engineering environments. So what it does is it constructs a collaboration graph which means it makes a graph that represents how the different programmers collaborated on a project. Now, the idea's origin story. The importance of knowledge management can no longer be overlooked in this modern day, fast-changing, flexible software engineering environment. Imagine you are a software project manager and you have a lot of programmers that work for you on a variety of projects. The more programmers you have and the more projects are actively running, the harder it gets to keep a clear overview on who has knowledge of what aspects of the code. And this lack of awareness can cause certain risks in terms of knowledge preservation to go unnoticed. For example, you have a programmer and he has written a lot of code, but he has written this all by himself without really collaborating with others. If this programmer decides to leave the company, you end up with code that nobody really knows the details of. So I believe that having an overview on how this collaboration is taking or took place can help you identify these risks in an early stage and help mitigate them. But I also believe that there are other insights to be gained from this overview, like the general structure of collaboration, who is a core team and certain sub-teams, but also you can identify crucial resources. Okay, so the idea is to make this kind of social network that represent your programmers as nodes and their collaboration relationships as edges between them. Of course, we need to have data to learn these insights from, and we took our data from version control system logs. These logs keep track of what programmers worked on and when they did this. And a lot of companies that are engaged in software development make use of these systems, like, for example, GitHub and Tortoise SVN. Now, we have the data, but we still need an algorithm that transforms this data into the graph that we want. So for this algorithm, we took our inspiration from both graph theory, but also process mining. Why process mining? We have this VCS log, and we try to discover a collaboration graph. So we want to visualize these relations. In process mining, you have a thing called process discovery, which takes an event log as an input and tries to discover a visualization, a model of the connection between these events. So what is this exactly? You have a log of events, and these events represent activities in a process. For example, a delivery process. And then you try to do process discovery to construct a process model that represents this process. So you try to discover different activities and links between activities. And what we try to do is we want to discover programmers and links between programmers. So it's very similar. That's why we took our inspiration from this. Now, to be able to use these principles, we of course need to transform this VCS log into an event log. And on a high level, you can see this as every record in this log represents a programmer that did a commit on a certain file at a certain point in time. And this VCS turned event log, we can load this into our program using the Bupar package, which was designed for process analysis. Okay, so now we have our input and we want our output. As an end user, you only need to call the build graph function and pass your log as an argument. And this will construct the graph for you, but you can also pass optional other parameters that let you control certain aspects of the construction. But I will touch upon this later. So you do the build graph function and it gives you a graph, but underneath there's a whole algorithm that of course constructs this graph. How does it work? It takes your log and it processes it through 3 different phases. First, it builds a base graph. So it includes every programmer it can find in the log and adds an edge if those 2 programmers collaborated on a file. This base graph is the starting point from which the different steps will refine the graph. So you have step number 2. It focuses on calculating a weight that represents an importance value for a programmer or a relation. And this has a dual purpose. First of all, it's used to emphasize important programmers and relationships in the ending visualization, but it's also necessary to be able to simplify the graph. Because right now we have a graph with a lot of programmers and every edge, and that is not very realistic. And also it's very cluttered graph, so we can't really extract any insights from it. So to calculate the importance value of a programmer, we took the weighted sum of 4 different metrics. Now, there is a default weight matrix, but as an end user, you can also choose to set your own weight matrix and let some of these metrics have more influence on the importance value. First, we have the unary frequency significance. This says, okay, the more often a programmer appears in the log, the more significant he is. Of course, for all these metrics, we also take into account certain constraints, like timing constraints and file importance. Next, we have the betweenness centrality, which gives a greater importance to programmers that are a part of different teams, so cross-functional programmers. The next metric is the AM vector centrality, which says, okay, a node is highly important if many other highly important nodes link to it. And the last one is the degree centrality, which calculates the number of edges upon the node. And it's used to identify isolated nodes, as they contributed to the project, but they did not really collaborate well with others, so you don't want to lose these programmers. They are important. Okay, so now we have an importance value for the programmers. We also want to calculate an importance value for the relationships between them. And we do this by taking the weighted sum of 2 metrics, the binary frequency significance, which says, okay, the more files are worked on together, the stronger their relationship. And we also have the proximity correlation, which gives extra weight when the programmers did pair programming, because pair programming is a closer form of collaboration. So after all this, we end up with a weighted graph. So that was step 2. Then we go on to step 3, and step 3 focuses on simplifying the graph. And it does this by going through 3 consecutive steps. First, we have edge filtering, which filters the less important edges. So for every edge, we calculate a utility value, and only edges with the highest utility values are preserved. Then the second step would be aggregation, in which we cluster less important but strongly connected programmers into a cluster, of course. These nodes are selected based on a node cutoff parameter, and they are aggregated based on an aggregation threshold. Both of these can also be set by the end user. Then the last step would be abstraction. Here we abstract insignificant programmers that are very weakly connected to the graph. So we remove them from the graph. And this is also based on that node cutoff parameter and an abstraction threshold that both can be set by the end user if he wishes so. So we end up with the result, and that would be a simplified weighted graph like this. Okay, now let's look at some examples. How do you use it? We take an example log. We try to build this graph and visualize it, and it gives us this iGraph visualization. As an end user, you can also choose to just directly access your nodes and edges. You can create an iGraph object that you can fully control the visualization of, or you can write your graph to CSV and use another tool to visualize your graph. I like to use the tool Gephi to visualize my graphs. So if we take the previous graph and visualize it using Gephi, we get this visualization. Now you can see a lot of colors here. We have different kind of nodes. The green ones are the cluster nodes. So they also specify how many members are in that cluster. Then you have different kinds of relationships. We have 3 kinds, and we have pair programming. We have disjunct programming, which means that they worked on the same files, but never in the form of pair programming. And you have the combination of the 2, pair programming and disjunct programming. So now let's tweak some parameters. There are many parameters you can set, but I think the most important ones are those for aggregation and for abstraction. So let's set those for aggregation. So that's clustering, it's the same thing. We have one that controls the number of candidates and one that controls the strictness of the cluster condition. So we will adjust them so that there will be less candidates for clustering, but the condition will also be less strict. For abstraction, you have the same 2 kind of parameters, one to control the number, one to control the strictness. Let's say we want more candidates for abstraction, but the condition will also be more strict. If we do this with the log, we can clearly see we only have 1 cluster anymore, but a lot of nodes got abstracted. Now let's tweak them one more time. If we say, okay, we want more candidates, but the cluster condition will be more strict, and we want less candidates for abstraction and a less strict abstraction condition, then you get something like this. We see a lot of clusters, and those clusters are really big. We have one of 13, one of 26 members. And you can also see that 2 pairs of programmers have emerged. Those were abstracted in the previous visualizations. Okay, now I will take this graph and try to explain some insights that you can get from it. So we have this graph. First thing that catches the eye are those isolated programmers in the corners. Those isolated groups are risky if they have very few members, and these members have a large importance. So that would mean that they contributed a lot to the project, but they did not really collaborate very well. So that makes them very valuable resources and not easily replaced. Another insight you could look at are the core developers. So you look at the heaviest nodes. Let's zoom into those. Okay, so these are the most important members of your project, but we can see that there are some of those core developers that have very weak relationships. So this is risky because they did a significant and important contribution to your project, but they did not collaborate very well. So this poses a risk of knowledge preservation if you lose these programmers. Another insights are some striking relations. I will discuss 2 right now. We have this group of 3 that those worked on a specific aspect of the code, but you can see the top one only did disjunct programming. You can strengthen their relationships by letting the top one also do, for example, pair programming. So there's more knowledge sharing between the 3 of them. A last thing I would like to discuss are these. Those are insignificant programmers, so the pink nodes, and they have a pair programming relation to a cluster. So that probably means that they are new programmers that are still trying to learn from other programmers in their groups to adjust to their new situation. Okay, so that are some insights that you can get from this graph. I'd like to thank you very much for your attention. You can also find the package code on GitHub. If there are any questions, please leave them in the chat. And thank you very much.
Perfect. Thank you very much for the great presentation. It was really in sync with my expectations, and also looking forward to all the related questions in a few minutes after the sessions. But now we have to move on to our next talk. So thanks a lot again. And our next speaker is Alex Gold, who will share some best practices and design patterns when it comes to creating larger Shiny applications. So Alex, please take the stage and you can go ahead with your presentation.
Thanks so much. It's so great to be here. Let me just get my screen shared. There we go. Just if you haven't used Hopin before, you can double click on the screen that's actually my little screen, and then that will be bigger. Great, thanks so much for joining this morning. Sorry, just starting my timer so I know what time it is. I'm going to talk a little bit today about design patterns for big Shiny apps. My Twitter is down there at the bottom if you feel like tweeting at me, and all of the code and a link to these slides is on GitHub if you want it. My name is Alex Gold. I'm a solution engineer at RStudio, so that means I work with a lot of our professional customers to help them figure out sort of how to architect big apps and to use RStudio products most effectively. So I spend a lot of time thinking about big Shiny apps, and I'm really excited to get to talk about it today. So we are going to start right off the bat with a Shiny app. So let's just get right to it. And let me pull up my RStudio here. So this is a Shiny app that I built. I live right outside Washington, DC. And for those of you who know Washington, here, I'm going to turn off my video because I think that'll make this run a little faster, I've been told. So it will just be my screen share. Machine is running a little slow, so I apologize for that. The app you'll see here in just a sec when it comes up is an app of the capital Washington, D.C. So the Capital Bike Share system is a system of docked bikes. You can take out a bike from one of the stations, ride to the next station, and dock it. And so Capital Bike Share is a really, really cool organization. They actually make data on bike availability available via an API that you can just access as you like. So this is a really simple Shiny app. All it's doing is it's just ingesting the data from their API and just displaying it here. So like I can click on a station and see that at Rhode Island and Connecticut, there are 10 bikes and 13 empty docks. At Wisconsin and O, there are 6 bikes and 13 empty docks. Down here, I have the timestamp of when this was last dated, and I can refresh the data and the timestamp updates as well as the data. So this is a pretty simple Shiny app. So I'm going to say right off the bat that since I'm talking about big Shiny apps, this is not a big Shiny app. This is a little Shiny app, which is intentional because I think maybe that'll make it easier to understand the code in just now 13.5 minutes, as opposed to having to understand a big Shiny app. But the principles I'm going to talk about here, I wouldn't really bother with for an app this small in general. So let's go back here. Okay, and let's talk a little bit about what we're going to do to this app to sort of make it a little better for it. So this is the code for that app. And let's sort of like split that up into a few categories. So we have like my Shiny UI here. This is the UI text. This piece here, this is all the server code, right? This is sort of like irreducible Shiny code. It's like managing reactives, creating outputs, that sort of thing. Like that has to be in the Shiny app. And then I've got all this, which is business logic. And some of that is easy to extract, right? Some of that is like, it just could be like a function that with an input and an output, really easy to extract. Some of it is a little more tightly integrated into the app. But the goal here, what we're going to talk about a little bit, is getting all that business logic out. And when I say getting the business logic out, it's not necessarily all of the business logic we're going to try and get out. You have to use some judgment about how much business logic is good to get out. But I've certainly found that pulling some of this business logic out of the app makes the app much more literate, much more readable, and much more easy to understand. And so let's talk a little bit about how to do that. The first and obvious way to do this is to write an R package, right? Put some of those functions into an R package. Definitely recommend that. Definitely use that. Or Shiny modules. That's another way to do this. And definitely recommend that as well. If you've taken those steps, or for whatever reason those steps don't sort of work well in the way you're working, I want to suggest sort of two other patterns. So the first is to take that business logic and put it into a Plumber API. If any of you haven't used Plumber before, it's a really cool R package that makes it really easy to write a RESTful API just using some R code. So that's sort of piece one. And then piece two is to take the connections in your app, including to that Plumber API, and wrap those into an R6 class. And I'll go through sort of an example of how that would work with this little Shiny app that we're playing with here. But these are sort of the two steps we're going to be talking about, is extracting that backend logic into a Plumber API and putting those connections into an R6 class. So just to sort of go over, like, again, just like visually how this would work, right? So we have our sort of monolithic Shiny app that we're starting with. What we're going to do is we're going to split the backend from the front end. So the backend's going to be in Plumber, the front end's still going to be in Shiny, right? And if you from other sort of web development frameworks, this is something you do all the time, right? You have a backend that's an API. The front end then is just responsible for displaying the data. And then what we're actually going to do is we're going to slot this R6 class in the middle because it makes it a little more intelligible to have your code written like this. So let's get to the code. So back to our studio. So let's just go walk through the code for this app sort of quickly, and then we'll start messing with it. So for those of you who are familiar with Shiny apps, and I assume most of you are, like, this should look pretty straightforward. So we've got our Shiny UI up here. In this case, I used the Shiny dashboard package to get that sort of nice dashboard with very little code. And then there are sort of three pieces of data here. The Capital Bike Share makes available sort of a main URL. And so you get from that a list of feeds. So this gives you sort of the actual feeds that you're going to look at. And then you can get individual feeds from that. So like a feed is the station feed, and the station feed has the latitude and longitude of the individual stations as well as their names. So like that was what let me put them on the map and put the name of the station in the little pop-up there. So that's one feed I'm going to use. The other feed I'm going to use is the status feed, which has the number of bikes at each of the stations at a given time. There is, then I have some sort of formatting and my outputs here. So this is sort of the general layout of how this is going to work. And so now let's start talking about how we're going to sort of extract this into a Plumber API and then an R6 class. So let's look at the Plumber API I'm going to write. So this is going to be my Plumber API. And what you'll see is I'm going to just basically take verbatim this code here, right? My feeds code here. And I'm going to extract that into my /feeds. If any of you have never used Plumber before, this is what Plumber looks like. It's really simple. You just write an R function, great. And then you make these special decorator code comments, and that auto-generates the Swagger interface for it. And I'll show you that in just a sec. But as you can see, I basically just copy pasted this code in here. I made the language that I'm using a parameter instead of just specifying that it has to be English. And then down here, I'm going to get the actual feed. And so that's combining both these like station getting code and the status getting code into one piece here. And so I now just have two API endpoints that I can use. And so I've actually got this hosted here on RStudio Connect. And so I can, for example, get my feed here. And now it's going to give me back all of the feeds. So now, like, if I want to look at the station information feed, I can just take that URL from the station information feed and give that to the URL here. And so like this is the data on each station and what each station is like. So now I'm going to make some little adjustments to the app itself to accommodate this that I'm going to show you here. So like this is the URL of that API that I've got running. And as you can see now, what I'm doing is I'm taking that code that was formerly sort of, this was the business logic, right? This was sort of extracting the right fields. This was my sort of data cleaning stuff. And I'm going to turn it into just calling my API. Similarly here, I'm going to extract this other data cleaning stuff and turn it into just calling my API. In this case, the effect is pretty minimal, right? I'm going to admit that up front, that like in this case, the amount of code I'm pulling out is almost the same as the amount of code I'm putting back in. But if you have more complicated business logic that you're using here in the app, pulling it into a Plumber API can make your app way easier to maintain. And I'll show you a real example of that in a minute. Excuse me. So that's piece one. That's extract your business logic into a Plumber API. So that's piece one. So piece two then is now create an R6 wrapper around your connections. For those of you who haven't used R6 before, it's a package that adds a new object-oriented way to create classes to R. So aside from the sort of S3 classes that we all know and love from base R, this adds an R6 class. And an R6 class looks a lot more like an object-oriented class from another programming language. So like if you're familiar with Python or Java, like this looks a lot like that. So you have your class name, your public fields and methods, and then your private fields and methods. And so what this allows me to do is when I have those connections, creating an R6 class that is the connection is a really nice pattern, because what it allows is it allows for the connection sort of details to be contained in one place, which is really, really nice. And then it allows me also to have very simple methods that are very expressive inside my app. So let's take a look at what that looks like. So now what I'm going to do is I'm going to, for example, take this content right here, which is like sort of my all this sort of initialization content, and I can just pull that into my initializing of the API. And so you can see down here, the way this changed the app is like, I'm going to just source in my class here. Obviously, if I were writing a real app here, I would probably put this in a package, because that's the way I would do this. But this is pretty straightforward. And now what's really nice is inside my app, all of this sort of initialization code, right? All of the getting the stations, getting the URLs, getting the feeds is just in here, right? In my bike client new. This reactive gets much simpler. I get to drop out all this, and it's just update status. And I have a few other calls. So let's see this actually in the app. And so in the, oops, I guess that doesn't like that. Let's reset here, since I don't care. And we're going to go to, I don't know why this is. We're going to pull up the right branch. And what you can see here is that after doing this, the app gets much simpler and much more expressive, right? This reactive, the data reactive, instead of having sort of all the actual data processing code in it, it just updates status. This makes it way easier to debug. Similarly down here, right, the last updated becomes this very simple call. And obviously some of these other things I probably would extract into a package, right? This would all just be a function, a single line function. Similarly down here, if I were adding a package, I decided not to go there for this demo because I didn't want to complicate things along the way. Where'd I go? Here we are. So just to talk through this. So now I've sort of shared like the what. Now let's talk about the why, right? Like obviously doing this is more work, right? Like you've got to do more work to build out three separate pieces of code rather than one. So this is not right for all apps, right? Like if I actually were building the app I just showed you, I would not bother with this because it is not necessary. It is overkill. But I hope you saw that final Shiny app with the R6 class is much more readable and much more expressive, right? There's less sort of boilerplate. There's much more readability. It's also much easier to test the individual components because you can test them outside of a reactive framework, which is really nice. That's really great. And then, and of course, what this results in is a much more maintainable code and app, which is of course the goal here. If you have sort of a high power app that needs to be maintainable, this pattern can work really nicely for it. So just in case you think I'm sort of like talking off hand, this is actually an app that we run at our studio. We run a lot of workshops, and in doing so, we stand up instances for each person. Each person gets their own EC2 instance with RStudio Server Pro and RStudio Connect on it. And so we have lots of classrooms going up and down all the time. For example, at RStudio Conf, we stood up over 600 instances for the conference. And so we need a way to manage those. And so this is the pattern we use with this app. We have a lot of connections going on here. We connect directly to the AWS CLI. We connect to a Plumber, actually a Python API we built internally to manage the classrooms. We connect to the database where the sort of student data is stored. And wrapping all of those things into an R6 class makes our lives way easier here and makes it sort of more possible to maintain this app, because this is an app that we need to maintain over a pretty long period of time. So with that, I'm going to wrap up. Thanks so much for paying attention here and tuning in. Especially thanks to Cole Arendt, who's one of my colleagues at our studio and who sort of introduced me to this pattern and has developed a lot of these ideas with me. I will put in a little plug for my own package here. If you like being able to use hex stickers wherever you want, I have a package called Sticker that's available on GitHub. And you can use it. It has a one-line function to get hex stickers for most R packages that have hex stickers in them. Again, please tweet at me if you have questions or comments. And the GitHub is there at the bottom. I think somebody dropped it in the chat here. I'll drop it again after. I also want to add that I didn't talk about Golem here, which is a really popular framework for doing these things. I didn't talk about it solely because I haven't used it that much, honestly. It's on my to-do list to play with it some more. But I think sort of the Golem piece helps you with your app structure. This piece can really help you with sort of the external connections to other resources. So I think the two can play really nicely together. Anyway, thanks for your time and enjoy the rest of the conference.
Alex, thank you very much. It's a really great presentation, also very efficient use of our time, sharing all these really exciting and important patterns and designs related to Shiny and async and all this stuff. I already saw quite a few questions in the sidebar chat, but we will have to get back there at the end of this session, so in 30 minutes. Before that, we will have to go on with our next two talks. So I kindly ask Ayomide or Shodipo to take the stage, who will talk about using AI or some kind of models to identify fake news or actually any fake products. So looking forward to that a lot. Ayo, the stage is yours, so please go ahead and share your screen and then switch off the camera just to make sure that things are running smoother.
Sure. Hi, everyone. I am Shodipo Ayomide, based from Lagos, Nigeria. I'm going to be sharing my screen now, and so let's get right into it. Okay. Chrome tab. I'm going to be sharing this one. Can everyone see my screen? Exciting. Okay, I didn't turn off my video. That's gone. Okay. So today, super excited to be at this conference. I'm going to be speaking a lot about, let me put this in full screen, fake news, AI on the battleground, basically the battle against fake news that we've all been seeing all around everywhere. How exactly do we solve this problem with AI, data science? Let's get right into it. So in this class, I'm going to be talking mostly about why fake news, where does fake news come from, what exactly is categorized as fake news, how does AI come into play and solve this problem, and also how does data science solve this problem also. So a little bit about me is, my name is Ayomide. I'm from Lagos, Nigeria. I work as a senior developer advocate at Fleek. Community wrangler, so I did a lot of community work for Unstack, Developer Circle Lagos from Facebook, Open Source Community Africa, and Africa Hacks. You can find me on Twitter, at GitHub at developer.io, developer then just AYO, developer.io, however you pronounce it. Okay. So why fake news? So fake news can be invented by anyone with access to something as simple as the internet. The way, why is the main question we should be asking and not the how. So fake news can be shared by anyone. It's as simple as you just going on the internet and you saying this and that exists, and when it doesn't, or A, B, and C does this, and when A, B, and C doesn't do that, that's literally fake news because it's not real. It's not something that actually happens. It's fake. But then why exactly do people do these things? Why do people create fake news? Why would someone just wake up in the morning and say, okay, I want to put something out there that's fake that will do something? So the reasons are, number one, hate towards a particular person or a country. You can have hate towards a particular person or a country, so you want to share fake news about that person or about that country. You can also want to take revenge towards someone as regards something. Then the third reason is political reasons. So this is one of the most popular reasons why fake news goes all around, which is political reasons. It can be anything that has just basically has to do with politics. So next is to promote a product or a service. So you can share fake news over the internet, over a newspaper, over the radio, just because you want to promote a particular product. And why would you want to even do that? Because number one is that it pays well. Fake news pays. Fake news is fake. It's too good to be true. I want to use that word. It's too good to be true. And people get to see them and are like, oh, wow, this is exciting. I've always wanted to see something like this. So I'm going to pay for this. I'm going to buy this. I'm going to purchase this. And when they purchase this thing, it doesn't even work like how they expect it to work or how the person selling service was going to work. I believe a lot of us have been in this scenario. Now, next. Now, how exactly does this pay? So fake news truly pays. Think of a product selling, a product A, B, and C for not knowing, now, A, B, and C for, let's say it's going to do this thing. But then when the customer buys this A, B, and C product, the customer automatically knows that, okay, it can do A and B, but then this product cannot do C. So automatically the customer knows, okay, I've been scammed, but there's nothing I can do. But then the product was being sold that I can do A, B, and C. That's a huge lie, and the seller will make a huge payout selling this kind of products because it's a lie. That's basically what's going to happen. Let's move forward. So where exactly in global, where exactly does fake news come from? How does it originate? Can we search for this fake news? So the number one place logically is the internet. Next is social media. So Facebook, Twitter, Instagram, these three major social media are where it comes from. So next, we're going to talk about radio, television, people on the streets talking about things that are happening that are literally fake. So we're also going to talk about newspaper companies. So these are the major places where these fake news are being generated from and are being shared across people. So what exactly is categorized as fake news? So what is categorized as fake news is any source of information that does not have a solid origin is considered fake news. So as long as the information, the data coming doesn't have an original source of where it's coming from, it's automatically categorized as a fake news. So how exactly does AI come into play of all of these things we're talking about? So the goal is to identify and differentiate fake news from real news. That's the original goal. The next goal is using these technologies and methods in data science to combat these things. So data science is a great technology that tries and find patterns in data sets, and this may be solutions to different differentiation between fake news and real news. And data science is the best way to combat this major problem. That's to differentiate what is real news and fake news. But before you can do that, you must also have a collection of data assets available already of what is considered to be fake and what is considered to be real. When you have these two different set of data, this is how you firstly start. But first things first, you must have these two set of data. So AI and machine learning is in particular maybe used to detect patterns and maybe characterize fake news when the human eye cannot see it. So there are things that AI and machine learning can see when so when you have a kind of like a set of data that probably categorize a way a sentence is being written, what is how punctuations is being used, what is how certain words is being used in a set of data that are considered fake. So once a new data is posted on this website, also in this data set we're also going to have the list of websites where fake news always come from. So this is just basically a data set we're trying to build up. So when we see this site also posting something out there on the internet, this same website, the same patterns, same ways, punctuation usage, the same words usage, similarly, automatically it's being categorized as fake news because of the data we have already. And when we have real news, we wouldn't be able to do this because we are humans and there are things that AI and machine learning can easily figure out than us just looking at them with the human eye. Only in the past few decades, there has been an effort to use AI to detect types of deception. Additionally, in the past few years, there has been an effort to use AI to detect fake news. The majority of the research is not focused on full news articles, but on short statements. So what produces more efforts and more credibility, not credibility, what produces more issues in the future is really mostly of the short statements made over Twitter, over Instagram, over these social medias, Facebook. They post a short statement out there saying, okay, this and that, A, B, and C, just a very short statement about something. Then people are, oh, wow, interesting. Then there's like a really long thread about that same discussion. Not knowing it's just a fake news that's just been generated and it's just going to get longer and longer and just people are just going to get used to like knowing this thing. So once it's let's say, for example, if something's trending on Twitter, a lot of people who take it to be real. If something's trending on Twitter, it might be fake news. No one knows yet because we do not have an accurate data to rank this as fake news or real news. We don't have that accurate data as of now. So automatically, if it's trending, that means it's something important and it can be real. So that's basically fake news. Let's move forward. How does data science come into all of this combat? So there's a data set that contains full-length articles such as Fake News Net, which is a small data set with supplementary data. So this data was collected from articles posted on Twitter and other social medias, which contains data such as profile of the user, who posted the article, and other social media content. So when, for example, my username on Twitter is as developer Ayo, so automatically when I continue posting data on Twitter that is ranked fake news. So in this data set, my username and the contents I post will automatically be registered under the Fake News Net data set as whatever tweets coming from this account is fake news. Because why? Over time, I've automatically generated like lots of fake news over the internet that has gotten a lot of people confused. So my account and every tweet coming to my account are going to be categorized as fake news because why? I'm putting data to this person that is ranking my account is putting my every tweet coming down from my account or any of my social media accounts as fake because that's what the data has learned to see in my account. So is everything really clear right now? Just take so much of a look and you would see the goal of all what we're doing today. So data is the key to differentiating what is real and what is fake. And that is what that's exactly what we do not have enough of. We don't have enough data to rank what is real and what is fake. And this is exactly what we need to have to combat this problem. And AI and data science changes the whole plane of how we see fake news and real news, how we differentiate in between fake news and real news, how we put data together. We must have data sets where we can say, okay, this kind of statements coming from this account are fake. This kind of statement coming from this account, these places, this websites are real. So ranking those data is what's really going to help us, and somebody needs to like get into this and make this work. So how AI comes into play again. So there's another data set called BS Detector, which is a list of websites labeled for what they are. So now under this data set, we have just a list. It's just as simple as a list of websites and continually what this kind of websites post. So automatically, when this website releases new content over the web or over Twitter, over any social media accounts, automatically it's being labeled as fake news, because why? It's under our list of the BS detector, the fake news detector. So number one, the categories include fake news, conspiracies, and biased judgment. So websites that produce fake news all over the internet just to sell a particular product, just to create a pandemic, just to create an argument, conspiracy theories about somebody doing something that is not true. There is no, so basically conspiracy is someone trying to say something is true with no accurate evidence that this is true. Yeah, that's a conspiracy. And if you post that officially on the internet, is wrong. You don't post that over the internet, and you don't push conspiracy without evidence. That's still fake news. So also think to the biased judgment. For example, you are putting up an article on your website talking about people of color. The recent people of color saying, okay, these people because they are black, this and this, they are automatically this. That's biased judgment. You don't do that. That's racist. So websites who do this kind of things automatically are being ranked under the BS detector as fake news. So once they produce content over the internet, automatically ranks as fake news. So classifying news articles, the raw text data needs to be turned into something more useful that could easily be understood. This process is called feature extraction. So basically what feature extraction is, it can take any form when analyzed. So number one, it takes the word counts, articles that are being posted on the internet. It takes how you use punctuations in your current article, in your past article, and how you construct it. So some people want to use three kind of words together, and that's just the way they write. That's just the way that author writes automatically. So we're going to analyze how you put your words together, how you use punctuation, where exactly do you put your punctuations, like your articles, how many words do you normally put in a sentence, how many words you normally before you put the next comma, how many words do you normally put together before you put the next full stop. These things are super important, and we need to take so much look at them. So we also need to find patterns in fake news. So we first, sorry, okay, I'm back. So first, the two kinds of news needed to be collated and labeled. So which is number one, fake news, real news, and represented roughly equal amounts. So we must have equal amount of fake data that is categorized as fake news and equal amount of data that is categorized as real news. So these two data. Basically, this is to avoid confusion between how the fake news and real news in the data set are being used as a determinant in classifying between real news and fake news. So when we have a lot of fake news, we have a data set with that, which is our fake news net, with a lot of data. We have over millions of data sets in websites, accounts that say, okay, anything coming from this account are fake news. And so just fake news is so much. But then under the real news data sets, we have let's say a few thousand, let's say 100,000 data. But then on the fake news side, we have a million. But then real news, we have 100. If these data sets are not balanced and we do not collect enough data, we wouldn't be able to accurately rank what exactly is real and what exactly is fake. Because in that case, we would have more fake news coming out and less of real news. And that's what we wouldn't want to have. So what exactly do we call a valid data? So valid data basically is good data in this context, is that is represented in the whole world and has a credible source. So the only solution to solving the rise of false and fake news is using technology available to us at our disposal, which is artificial intelligence, AI, and machine learning. If we do not have enough data of past strategies used by fake news, and these people currently putting fake news out on the internet, creating biased judgments, creating a pandemic, creating conspiracy theories, we wouldn't know exactly how to study them. We would most likely fall prey to the security breaches we had before, and we fall prey to them again. And this is what we do not want to fall prey of as a country, as a person, as anything. We just want to be making everything as straightforward and as simple as possible. So thank you. Any questions? You can reach me over Twitter or GitHub. I have a couple of projects on GitHub. I tweet a lot on Twitter at developer.io. So yeah, you can reach me over there. Yeah, with any questions and anything. So thank you.
Thanks a lot for sharing all the details about this really cues of R in the background, and I'm sure there will be some questions coming up, but as said previously, we will have to wait with those until the end of the session. And now I kindly ask our fourth speaker to take the stage, who is Henrik Bengtsson, who is at least the second time speaker at e-Rum. I remember his talk from 2 years ago, which was fantastic, and I'm sure this one will be similarly like not only useful, but fun as well, which is about unified API for progress bars. So really looking forward to that. Henrik, please take the stage and start with the presentation. Thank you.
Thank you. Good morning, everyone. I'm calling from a sunny morning in California here. I hope you're doing well out there. I'm going to share my screen. And I'm going to try to turn my video off. There we go. And now you should all see my screen. Thank you. So my name is Henrik. I'm a faculty at University of California, San Francisco in Biostatistics Department. I'm a member of the R Foundation, and I'm also sitting in one of the groups in the R Consortium. I do my research in cancer genomics, large data set. I do parallel distributed processing that takes days to run. That's an everyday work for me. And this package that I'm going to present, progressr, which provides an inclusive unifying API for progress updates, grew out of this type of work and needs. So for this talk, we're going to need some code examples. So imagine we have a function called slow, and it's going to take about 1 second to complete, and it does some magic calculations inside we don't really care about. And we next going to apply this function to each of the elements in a vector X with here an example with 50 values. We use the lapply function to do this, to call the slow for each of the elements. And if, as we all know, we run this and it's going to take about 50 seconds to complete. Now, if there's a user that comes around and doesn't know that this is going to be slow, they're probably going to wonder after like 10, 15 seconds if things are actually working. Did something crash or did it stall? So this brings us to the first point of progress updates. We want to know that things are still running when it's slow. And it's nice to get some kind of heartbeats while it's running. Even better if it's can tell us how far we've done in our computations and how much longer it will run. And this is typically where we have progress bars in the terminal, and they can show you the % completed this far. And a good progress bar will also give you an estimated time of arrival. How many seconds, how many minutes, how many hours, and maybe even days that are left to run. And I would like to emphasize the longer our process is running, the bigger the need is for progress updates to the end user. So let's do an overview what's available in R. There are a few options for doing progress updates in R. And if you have a fresh installation of R, you're going to know that it comes with the utils package and it has the text progress bar function. It's a basic functions, but it's good enough and can serve the purpose of most progress bars. And the gist is that when you do the lapply call over slow, before you do that, you set up the text progress bar and you say the number of steps here, max equal to 50 it will become. And in each iteration, you update it, and you do that with a set text progress bar, and you update it such it takes the current value with get text progress bar and add 1. And when we run this, it will provide and produce a neat progress bar in the terminal. You probably also heard of the progress package. It's a package that gives beautiful progress bars. Gergely, I actually lost my time my timing. So could you please tell me after 10 minutes?
Yeah.
Thank you. So the progress package, it's a package by Gabor. It's on CRAN. It's very powerful. I'm just going to show a very basic example here, and I really encourage you to look at it. You've probably seen it in action if you use tidyverse and other things. It's a great package. And the concept here is very similar to what you saw before. You set up a progress bar, you say the total number of steps you want to run, and in each iteration you call the method tick on this progress bar, and it will increment this progress bar and generate a terminal. So there are a few things we need to be aware of when we run and create progress bars. And one of them is that as a developer of a package, if we say we have a function we call snail, and this function calls that lapply inside, we probably want to give the user an option to render and display a progress bar or not. So we do that typically with an argument called progress equal to false, and if that's the default, nothing will happen. It will just run the regular lapply. However, if a user who wants to see a progress bar or get progress updates, they will call progress equal to true, and the progress code will also come in play, and it will render that in the terminal. However, we are going to have to be careful with other output while running these progress bars. So there are ways to work around this problem, but a very simple one is to just say, if you have progress bars generated in a terminal, do not do any output. So that is shown here. This message function that I call is not done if I do progress. If we would do it, we would get something that shows like this. They would compete with a space and output. You get a little bit of a message, then you get the progress bar trying to display itself, and then followed by another message and a little bit of progress bars, and it's going to be a mess in the output. So the simplest one is just disable output while having a progress bar. And the big point here is like progress bars don't work when you run in parallel processing. And this is very unfortunate, because one of the reasons why we do parallel processing in the first place is because things take a long time, and that's when we really need to know progress. So you're going to see a lot of attempts and a lot of questions out there of trying to use progress bars, and there are some hacks, and none of them are actually correct. I can't go into the details there, but here is a typical example of an attempt, and I've done this too. It's using the parallel package to set up a cluster for background workers. It creates the progress bar as usual, and then we export the objects that each of the workers need in the cluster. It needs to know about the slow function and the progress bar. And then we make use of the par lapply. This is the parallel version of lapply that comes with the parallel package. And we lapply over it, called tell the progress bar to update itself and calculate slow. If we do this, you will find that there will be no progress bar visible. And this is because output stays with the workers. It's not relayed up to your main R session. There are other reasons why this also doesn't work that I won't mention here. And this is not just because the progress package. This goes with all other solutions out there that I'm aware of. It's an essential problem of parallel processing. So, but we can do better, because R got something really awesome called the condition framework. And this is where the progressor package comes in. So it's a unifying API for inclusive progress bars, updates, trying to avoid using bars, because this is not just about bars. And just to make sure it works with for loops, while loops, lapply, per, for each, whatever MapReduce you have out there. So no surprises. This package is on CRAN. It comes with 2 APIs. One of the APIs is for the developer, and the other is for the user. So the developer needs to focus on creating a progressor. And that's basically saying how many steps you want to do. And that returns a function. And then you call that function, it's created, and that will signal progress. So just focus on where in the code you want to tell progress is happening. The user is only caring about whether they want to see progress or not. And they can also control how it's rendered and displayed or through audio. So here is how it will look like. So it's very similar to before. We have this snail function that is slow. You set up the progressor before your lapply, and then within each iteration, you call the p function. I choose to call it p. You can call it whatever you want, but I find p neat.
You have 5 minutes left.
Thank you for that. So in this, what happens here, so it looks very similar. You create the progressor here. In the past, we created progress bars. Create a progressor. We call this p to update it. And what happens in the background here is this is actually signaling a progress condition. And it goes through the R's condition system. And another thing you will notice, there is no argument here that the user can specify progress equal to true or false. And that's actually by design on purpose. I'll explain soon. But so from the outside, it looks like a regular function, and it is a regular function. Oops, I guess I had some timer. So there is, so if the user just called this snail function as is, nothing will happen. It will behave as a regular function. There will be no output. However, a function, a user who calls with_progress, and inside put the expression they want to monitor with progress, it will output the progress bar in the terminal. So that's the user's way of saying, I want to see progress or not. So there's no argument passed, but they wrap the expression within this with_progress call. And that's another neat thing is like the user can choose different way of presenting progress updates. So here is a user saying, I want to use the progress package, and I also want to use the beeper package by Rasmus to render my progress updates. So a user that uses this will get the progress bar, but it will also get sounds when the processing starts, and then a few cue tick sounds along the way, and then a big happy catching at the end when it's done. And so, okay. Another thing you with this package is that you don't have to worry about output. Cat and message will just work. So you can just put a message in here, and the framework, because of the way it's designed, will make sure they don't compete with the progress bars or whatever you have in the terminal rendered. And the big thing, it will work with parallelization. So progressor exists because of frequently asked questions in the future framework. And if you don't know about futures, it's a unifying API to do parallel processing in R. It's a very powerful thing. You can use your favorite MapReduce parallelization framework. For instance, future apply, for each, bias parallel. And this is how you need to update your code. All you need to do is to change your lapply to future lapply. And this code will now run in parallel if the user asks for it to do. And the user asks for that by specifying, in this case, I want to run multi-session in parallel. And that means running multiple processes in the background on the local computer. And then they say, I want to use with progress to see progress. And this will just work. And yeah, they will get the progress bar, even if this runs in parallel. And point is, as a developer, you don't have to worry much about this. It will just work. As a user, it will just work. And it will even work if you have distributed processing. So if your workers are running somewhere on the internet, thank you. the progress information will come back to you, and it will render in your local computer. So take-home messages. Developers decide what the progress to report on using a progressor function and signal progress. End users say if they're interested in it or not, then they can also control how it's rendered. You don't have to worry about output clashing with progress information displayed, and it will work in parallel processing too if you use the future framework. So I want to leave you with, encourage you to go out and create new progress handlers for end users. So we have existing ones. We see in the text progress bar. We have the progressor progress package, beeper. I didn't mention this also works with Shiny, but I would like to encourage you to go out and create progress updates for push-bullet, Twitter, Telegram, SMS, email, or if you have smart light bulbs, flick the colors of those when the processing is done. And my last slide, there is the cool package that came out as a proof of concept by Mike FC, Rancid. It can render images in the terminal. So I hacked together a progress updater handler for this. So it works like this. I just tell I want to use this handler and I call my snail function and it starts running. And if you look over here, it's also present the percent update while it's rendering this image. And I think I want to leave you with that. And thanks you for the attention.
Thank you very much. Like really great delivery of your talk as usual. So thanks again. Now I kindly ask all our speakers to join back so that we can start with the questions and answers. Let's see. I still only see Henrik. Okay, Leen, Alex there, waiting for IO. Okay, great. So I would like to thank you all again for the fantastic talks, and we got quite a lot of questions in the sidebars, and I got some help with compiling those into a list. So what I would suggest is let's take one question, each of you, and let's just do that in the order of the presentations, and then we can after that switch to like further questions in random order as well. So the first one is for Leen from Alexandros, and the question is, are there other functions in the package that can look at multiple repositories, like so that one could get some aggregate statistics in the sense of someone participated in the development of a given repo, collaborated with some others, and so on. So if we would like to use this in a non-mono repo setup.
Okay, thank you very much for the question. With the code as it is right now, it is not possible to get your desired outcome in total, but you can tweak the input a bit. So what you can do is we have this event log, but instead of using file IDs, you can use your repository IDs. So then you can make a graph about people working together on repositories, but you will still lose the working together on files. So another thing, what you can do is make a graph per repository. So for each repository, you make a graph and you combine them, you compare them. There is no direct way to compare your graphs right now in the package. So you have to do it with another package or manually. What you also could do is you take all the repositories and you make it into one large input file. So you make one event log with all the commits on all the repositories. And then you make one graph, but you still lose the difference between the repositories. So the entire goal of what you want to reach is not possible right now without adding to the implementation.
Quick follow-up question. So is there like a layer between repos and files, maybe looking at who collaborated on the same branch of a repo? If
No,
that makes sense, maybe not.
Not right now. So it's not implemented yet.
Okay, cool. Thank you. Right, next question for Alex. The first question was asking about your thoughts about the Golem package, if it something you would recommend? And I know that you answered that really briefly at the end of your talk and in the sidebar, but if you could just reiterate that with some more details, that would be great.
Yeah, absolutely. So Golem is a great package. I know Colin is presenting, I think, on Golem at some point this conference, so I'm definitely going to be tuning into that talk, and I hope others will too. I think Golem takes care of part of this. So like Golem helps with the separation of concerns within the Shiny app, which is really another important piece here, right? It makes it sort of easier to use tools like Shiny modules and that sort of thing. Actually separating your external connections into an R6 class, I think plays really nicely with the way Golem works. And so I think they're complementary ideas. And I think Colin and I even have tweeted at each other about this idea and both been enthusiastic. So I think, if you're using Golem or if you're building big Shiny apps, Golem is a great way to go. The sort of ideas I was talking about separating out the back end, putting that into Plumber and R6, I think plays really nicely with Golem.
Cool. Thank you very much. Let's big question for IO.
Yeah.
Okay. Are those data sets that you mentioned in your talk publicly available and can be used by anyone in the attendees?
Okay, yes. Thank you for that question. So for the fake news net, and other data sets like the VS text I mentioned, they're not publicly available. They're privately owned by institutions, but everyone is open to creating their own data set they could use, and they could also share openly that anyone could use. But those ones I mentioned are privately owned. Yeah.
Thank you very much. And question for Henrik. The first one was comparison about the PB apply package. So if you can just get back to that question and highlight some differences that you think are important.
How far is this up? I see one. I'm seeing asking.
Yeah, so
pardon.
The actual question was PB apply package does everything shown so far, including the parallel execution with progress bars with remaining time. So is there a reason not to use PB apply instead of your package?
If you already use it and are happy with it, definitely stick with it. So I want to comment about this. So there is 2 updates from parallel processing progress bars, and the approach done in PB apply and many other approaches is that you get updates when a worker is done with a task. So if you distribute things and each worker runs for 2 hours, you will not see that update within 2 hours. But with this approach, you will get update while the worker is running too. So that's a big difference. And so yeah, that's the answer to that question.
Okay, thank you very much.
It's a very good question. Thank you.
We got quite a few really technical questions as well. So I would suggest let's go ahead with those. And then if we have time, we can focus on some of the more general questions as well. So one for Alex is basically a comparison of the Plumber package to REST rserve. If you have any comments on that.
Yeah, I don't honestly know a ton about REST rserve. I know it supports parallel processing natively, which is nice. For Plumber, you have to do something like fork it into processes. You could do that using Docker. RStudio Connect supports that. So it doesn't do parallelization quite as naturally. One disadvantage of the way REST rserve handles parallelization is I believe it does it via Unix forks, which isn't going to work nicely if you have like a database connection via ODBC. So there are advantages and disadvantages. The main point here is I would argue that it's good to split out your backend concerns from your front end concerns. If you're more comfortable with REST rserve or that works better for your use case, that's great.
Thank you. Henrik, a rather technical question for you. How do you actually calculate how much time is left to end a task? It's extrapolating and fixing while on the go.
Okay, so that's a very good question. And the very simple answer, I do not do that because I don't have to do that in the progressr package is just a wrapper around existing progress bars, etc. So in this example, I can pass that on to the progress package, and it has its way of estimating that. But if I can start guessing, because it's a hard thing to predict how long. So I think what the progress package is doing is just looking, it's a linear extrapolation. And I don't think it's very time consuming to do it. But of course, if you run things in only a few seconds, it will add some overhead. But so short question, progressor is a very thin layer. It doesn't really care about how things are done and what's presented. That's taken care of about the handler itself.
Thank you. Let's get back to Leen. There's a question, why don't you include a quantity metric for the amount of code the developer commits to compute the collaboration graph?
Okay, so we take into account the number of files and file importance that can be calculated or provided by the end user. But I think if you mean the amount of code like in a file, how many lines, I don't think you can really put an importance value on how many code lines you write, because some programmers write more compact code, some programmers write more spacious or comment more. So I don't know if you can really learn something from the amount of code directly without having maybe expert knowledge. So I could include that, but then you probably need to know some expert knowledge about the project you're analyzing.
Makes sense. Thank you. Question for IO. I see there is a problem in detecting fake news by interpretation context of certain news. Is AI able to detect fake news by its context?
By its context, so I said earlier during my talk, so automatically, the BS detector automatically ranks. What he searches for is, number one, how you construct your sentence together. So how exactly do you put your sentence together? What kind of words do you use together? Usually, so it ranks by accounts. So let's say this website, www.abc.com, automatically is going to say every content, it's going to analyze every statement in this website saying, okay, so this is how these words are being used. So every time these sets of words are being used at this time, this same way automatically ranks, okay, so this is a proposed fake news. But then in respect to validation of how exactly this is, so it automatically ranks this on this website because it has done that consistently. But then in respect to validation, if this is really fake news, so that's where you would have to like do them normally, because in this case, it's automatic because of your track record of posting fake news before. Every content coming from your domain, from your URL, from your account, Twitter account, Facebook account, automatically ranks as fake news because of your past track record. It's as simple as that. If you do not want your content to be ranked as this, you would not post conspiracies, fake news, or biased judgments. Automatically, if you do these things, you are being ranked as fake news. I'm not sure you will need validation if you have a track record of posting fake news.
Thank you. There are still quite a few comments and rather praises, not real questions, so I will try to filter those out. There's one for Alex. So this starts by saying that you really made a case for a larger production Shiny app. So how would you make the case for people that are also using some other JavaScript frameworks like Vue.js, Express.io, Angular, and so on for the front end, and not only use R for the backend work? So what's the case for Shiny interacting between these two?
Yeah, I would say if you're comfortable with those front end tools, or you have a team who's comfortable with those front end tools, like go for it. That's great. Putting R behind a Plumber API, I think, is a great way to like easily integrate whatever you're doing with those front ends, and that's really exciting, I think. You know, I talk to a lot of folks who are primarily R developers, and so they don't want to have to learn Vue or these other front ends. And a Shiny app is just such a quick way to be able to have that interactive front end. I think, probably Vue and some of these other frameworks are more flexible in some ways, but they're also a lot harder. And particularly if you're primarily an R developer, the leap to Shiny is very small. The leap to some of these other tools are bigger. And so it really just depends on what tools and what skills you have with folks you're working with. So that would really be the only limitation for me is do whatever your team is comfortable with. In many teams, Shiny is the quickest and easiest thing to do. So if that's what it takes to get a production app going, have fun with it.
Henrik, one for you. Are you using progress bars, an API, a standard way to track progress in non-interactive long processes? But can you recommend anything beyond just writing occasional status messages to a text file?
Oh my, this is a hard problem. No, so this is about batch processing, and I assume long-running things could be like hours and days, for instance, here. Yeah, so it's a very good questions, and I think the progressr package framework, the philosophy with that is just starting to scrape on these things. So one thing I didn't mention is you can actually, when you signal progress, you can send along other information like a message and stuff. And if the handler supports presenting that message can also be outputted. Another one is to do what we're all doing is outputting messages and look at the long log file. You could also here write like push bullet things. So if you have a handler for push bullet, you could get that signal to you and have that as your way of following these long running processes. But the really cool thing here is I think all these log frameworks we're seeing that exist in R, several. We have one on this call that developed one for sure, Gergely. I think they can also use the condition framework. And you can imagine that the progressr package grows out to support the log messages too. I'm not going to do that, but I hope someone takes over that thought and runs with it. So I think that's the long-term solution to this question.
Really cool. Thank you. Another question for Leen. Do you have a preprint of your paper extracting a collaboration model from version control system logs based on process mining techniques available somewhere?
Yes, I have one on ResearchGate. You can request one, and I will also add it to the GitHub repo, so you can read it there.
Really cool. Thank you very much. Alex, if I understood correctly, you advocate the use of R6 for the logical pieces of the application. So when would you use it versus like regular functions? Is it mostly for HTTP requests or other connections?
Yeah, that's a great question. In general, I found that it's most useful for connection kind of things. You absolutely, you can't use it for other things. But using R6 results in code that's not very idiomatic R code because it is a framework that much more closely resembles object-oriented frameworks in other languages. So you can end up with something that looks sort of like Python code in R, which is weird. So I've found that for those sort of connection things, it's really useful to be able to sort of encapsulate all of that inside an R6 class. For more sort of general programming tasks in a Shiny app, I found that using, if you need an object-oriented framework at all, an S3 class is usually more than sufficient. But for those connection feeling things, those can really be more easily encapsulated in an R6 class.
Thank you very much. Henrik, you wanted to add some comments on that, just so you switch on the microphone, but okay, maybe not.
No,
sorry.
No.
Okay.
No, thank you.
Then I think we are kind of running out of time, but let's have like another question. And Henrik, there was a comment stating that your work is fantastic, and I really love your work with the future suite of packages. So thanks a lot for that. What do you plan for the future of these packages? What ideas you have in mind, and what's next?
Wow. I anticipate one final hit on enter and I'm done. No, no, there are a lot of new backends that are probably going to be added by different users. I can anticipate the contributions that people write cool MapReduce frameworks out there. I don't want to indulge in the future framework, but there are a lot of stuff that can be done generalized and simplified, and everything while being backward compatible. So yeah, I can have an offline chat with that, and we can talk for an hour about it. I love to talk about that. Can I?
Yeah, go ahead.
Are we done with the questions and answers now?
I think so, but you have something in mind, so.
Yeah, I have. I want to really take the time to thank the organizers, because I know you guys worked for a whole year and more to plan on this event happening in Milano. And we all looked forward to go there. And I hope to go there another time and meet everyone in person. But I can't imagine having to like cancel that and then find the energy to restart and create this wonderful online event. And I think everyone here in this room and listening and the whole R community is very thankful for this, and you're setting a new standard. And there are a lot of people that are going to follow this lead. And so thank you very much. Thank you very much.
Thanks a lot for the organizing team. It was really fascinating to see that there were like 300 folks following your talks in the past like 1 hour and listening to the question and answer session. So thanks everyone taking the time to join and ask all these great questions. Thanks a lot for our speakers for the great presentations and really spot on answers for all the random questions we had. And I would suggest everyone to continue with networking. There are some pretty cool features here on Hopin for that. And yeah, thanks a lot, folks. I guess that's it for the session, and have a wonderful day. So see you later. Bye-bye.
Thanks all.
Thank you, everybody.